Thank you. First, I want to thank everyone for getting their homework assignments in. Um, the homework three, question one, if you recollect, had the question of what should your UWM's Concrete Sustainability and Resiliency Center address? And the group, the class put forth 10 very good suggestions. And on the screen, you'll see just a summary of these topics. By far, the most popular topic was the use of plastic in concrete. Now, some suggested using microplastics in concrete, others using the plastic as aggregate. Also, there was the use of plastic in asphaltic concrete. Um, Going from there, we had other suggestions like using, studying pervious concrete, lightweight concrete, recycled concrete in art form, attractive type concretes, as well as making new concrete. There was the idea of making long life concrete, concrete that can last over 200 years. I have stood on concrete pavements that are over 100 years old, 125 years old, in both North America and in Europe. So 200-year concrete life is not unheard of. It certainly is achievable. Um, Also, blockchain construction management, basically sharing information on the project, something like a building information management tool. There was also a suggestion of using seawater in concrete. One of the things that would have to be overcome is the corrosion of the steel rebar in concrete. So how could that be addressed? So I thought that was a very good suggestion because concrete does use a lot of fresh water, and fresh water is getting harder to find, especially in states like California. So if we could find ways to use seawater to make concrete without the corrosion problem, that could be a huge benefit around the world, especially for countries that have access to seawater. There was a suggestion to use waste concrete or demolished concrete as aggregate in making new concrete. Also, I thought this was a unique concept of using HCl, which basically is a form of hydrochloric acid coming from the emissions of industry plants, cement plants, and so forth, to treat some of the recycled demolished concrete to make it more useful in making new concrete. So I thought all of these were excellent ideas, and I want to thank everyone for your submittals. Are there any questions? I'm not hearing or seeing any
I
questions.
want to add that these are fantastic ideas. We have some of them as business projects, and we are very open to kind of coming the ideas from you for implementation. So if you think you can develop your idea and you want to kind of do some experimental kind of activity on it, we are always there, and we would like to kind of see how you want to kind of develop your idea, and you can come to USR and we can have a plan and kind of uh, have your ideas implemented. So please take consider that as well.
Very good, thank you.
So is there any question? Let me see if Marina is joining us.
Rose, your microphone is very low.
Oh,
I
sorry
don't
for that.
know.
Now, can you hear it now
No.
better?
Now it's a little better, but it was very low. Sorry.
Yeah, I don't know, it's the problem of my headphone or the PC. I can try another computer if my voice is so blur.
Yeah, that's certainly better.
All right.
Yeah, that's good.
Uh, so guys, last week we talked about the benefits of geopolymers, and as Dr. Sobolov mentioned last week, maybe we want to kind of take a look at the empty portion of the glass and see what disadvantages geopolymers have compared to concrete. So, do you think just you can kind of brainstorm and see what disadvantages can are geopolymers having in comparison with regular Portland cement concrete? Do you have any idea?
Say, Bruce, I'm wondering if, oh, we forgot to record. Are we recording?
No, no, we are recording.
Okay, good, good. Okay. I was wondering if we could open up a
Sure.
blank Word file just to kind of type in some of the the suggestions or concerns that folks may have on geopolymer.
All right.
For example, one of the concerns that the user community had with geopolymers back in the late 80s and early 90s was the very high alkali content. An alkali content of, say, around 14% potassium hydroxide that really scared a lot of professionals. At that time, um, many people tried to keep the alkali content from a sodium hydroxide standpoint lower than 0.6%. And suddenly there's a cement here that has 14% alkali content, which scared the heck out of people. And of course, the reason that they were concerned was due to this reaction of alkali silica reactivity, which is a reaction between the sodium or potassium hydroxides and siliceous aggregate, which creates an expansive reaction, an expansive gel in the concrete. So basically, the aggregate is expanding, or this gel is expanding, and that causes the concrete to crack up, and it can be completely shattered. Whether this is a foundation for a bridge or a pavement or a structure, you can basically end up with a concrete structure that looks like shattered glass. And that reaction really has destroyed a lot of structures in the United States, Canada, and around the world. So this is something that people had a lot of fear about. Now, the thing is the chemistry of the alkalis in the geopolymer cement are a little different than what people were finding with the reaction, alkali silica reaction in regular uh, Portland cement concrete. So the challenge was to try to appease folks or address the concerns that people had. And quite frankly, I don't think that the producers of that product did a very good job of alleviating those concerns. So that is one of the concerns that people had with the alkali activated geopolymer cements. So that would be one item to post on the list of concerns with geopolymers. Beirut, are you able to post a Word document up and list some of these
Yeah,
items?
yeah. Just a second. Just a second.
So I have a question in regards to the alkali silica reaction or the alkali aggregate reaction. So does it mean that geopolymer concrete can still be used in certain application as long as there is no reactive aggregate? Or like what is, I guess, what is the current qualification to ensure that geopolymer is a good fit for a
Mm-hmm.
specific project?
Yeah, there's two answers. First, um, the you can use geopolymer concretes with non-reactive aggregates. So let's say you have a limestone or a dolomite aggregate that has no reactive silica in it. Certainly, that would be perfectly fine. Also, the scientists that were studying geopolymer, the alkali activated geopolymer cements, basically found that when you get to a very high level of potassium or sodium hydroxide, there's a point at which the chemistry kills itself. And so they found that they could use this geopolymer cement with reactive aggregate. So that was very promising. The problem was is that even though several researchers found that to be true, it still made the specifiers a little nervous. So the answer is yes to both questions, that you can use the high alkali geopolymer cement with and without aggregates that have reactive silica.
Okay, thank you.
You're welcome. Good question. And with today's aggregates, it used to be that people could say, well, I'm just not going to use the reactive aggregate. Well, today, we have used up a lot of the natural aggregates that are not reactive. And so now we're forced into using the reactive aggregate. For example, if you look at some states like, say, Pennsylvania. Pennsylvania studied all of its aggregate quarries and found that around 80% of the aggregates were reactive, slowly reactive, but they were still reactive to the alkali silica reaction. So they had to find ways, the state had to find ways to specify how to use their aggregates to control the reaction. Otherwise, what was happening to the state was many of their concrete roads were simply developing very extensive cracking within 20 years. And it was definitely causing some durability problems. So that was a concern. What about supply? The geopolymer product that I mentioned, which was called Pyrament by Lone Star, which is a company that doesn't exist anymore. They used slag in making this product with the potassium hydroxide as the alkali activator. The problem is that we use all of the slag in this country already. I think the United States has something like a 4 million ton supply of slag, and all of it is used. So there's certainly a problem with supply and demand. You would not be able to replace all 100 million tons of cement that the United States uses with a geopolymer cement, simply because we don't have slag as an option. There just simply isn't very much of it. Now you can make geopolymer cements from non-slag materials. Some fly ashes can be used, and there are other zeolitic type minerals that can be used to make these materials. Anyways, I just want to point out that supply, or the amount of necessary raw materials, could be an issue in trying to provide what the public needs. Okay, any other ideas, thoughts, or concerns about geopolymer?
Steve,
What
do
ab-
we have, because one of the concerns regarding the geopolymers may be the durability. Do we have like a real field project implemented in US or Canada, just made of geopolymers that the kind of durability were examined on it?
Yeah, good question. Durability long term. There are several structures, especially pavements, airport runways, that have been made with the geopolymer cement concretes, and they are performing very, very well. Geopolymer concretes have been put in test sites. The Army Corps of Engineers has a test site called Treat Island, which is off the northeastern coast of Maine, and it is simply used as a site to put large beams of concrete, test concrete, into the ocean on the beach. So the samples are exposed to seawater in a freezing environment. And there, the geopolymer concretes are performing extremely well in that environment. So durability of these materials seems to be very, very good. So that's good. What about safety? Would you want to put your hands in a material that has 14% potassium hydroxide? I know I certainly would not. So regular Portland cement concrete with the calcium hydroxide is bad enough. I mean, you never want to handle concrete with your bare hands. I've seen, unfortunately, YouTube videos of people placing concrete either in tennis shoes or bare feet, and people are basically asking for severe skin burns, second and third degree burns with that. So there are additional safety concerns that people may have with this very high hydroxide concentration. So that would be certainly something that you would have concern about with regular Portland cement concrete, but even more so with the geopolymer concretes. Any other questions of disadvantages? Dr. Sobolev has joined us.
Just another question.
Yes, I'm here. I'm still trying to
Hi, Professor.
see how I can connect headphones.
Darius, go ahead.
Steve, with this high alkali content, if we use geopolymers in the regions where they have like air pollution issues, and if the acidic rain kind of comes, is there any concern comes up?
No, I don't think so. I don't think that you'd have concern with runoff or other impacts on runoff water any different than Portland. I think it would probably be about the same.
So another thing, yeah,
Well,
go ahead.
Oh, sorry. I had another question in terms of the curing of the geopolymer concrete. How does it compare to like the regular Portland cement curing? Would it be comparable, or would it require different type of curing?
Curing is very, very fast with the geopolymer. Geopolymer concrete can achieve equivalent design strength of a Portland, where a Portland can take anywhere from 7 to 28 days to achieve its design strength, whereas the geopolymer can do that in a few hours, be it 2 hours to 6 hours or whatever, and you can control that. So the curing can be much shorter because the material achieves design strength at a much faster rate.
I think
Okay, thank you. And with, oh, sorry.
Anita, very good question, but I'd like to add to Steve that sometimes the commercial products which Steve mentioned, they really tuned for fast curing. But some compositions, especially in like high fly ash compositions, actually what we've seen, they would require even accelerated temperature, elevated temperature to cure. One of this, again, links I sent to you is to discussion of the forum of ACI. And I really encourage everyone to look at this because you have introductory opinion about geopolymer, and you can look on geopolymer website and look at how wonderful material is. But you know, in this class, we need to get like some critics and just to understand how material works. But some geopolymers, and I don't see Marina on the participant list, but for example, they had to cure at elevated temperature, like fly ash based kind of lean compositions. They may require even like heat treatment to cure. And but as Steve said, most of the compositions we know, basically not fly ash but blast furnace slag based, liquid glass or hydroxide, sodium hydroxide, for example, those are really fast curing. So you can have both type of ways. I don't know if you looked at, and again, I will need to leave relatively quickly. I have maybe another 15 minutes. So I still like to bring it up to the discussion. If someone looked at the main component of the geopolymer, such as sodium silicate, sodium hydroxide, and sodium or potassium hydroxide, and or potassium silicate. For example, if you look on the production of this material, so what is involved? What is involved in production of first hydroxides and silicates? Silicates are produced from hydroxides by autoclaving silicate source and hydroxide. But what is involved in production of hydroxide? I don't know, Anita, do you think you can recall it? We don't have Philip on the call. Philip would give us immediate answer, but.
Sorry, I cannot hear you very well. Are you asking about silica? Can you repeat question?
My question is that we have a good understanding on byproduct portion, but we don't have understanding on what is involved in production of hydroxide, sodium hydroxide and potassium hydroxide. Do you remember this technology? What is involved?
No, I don't. Sorry.
This is where we need to look, manufacturing. I'm just Googling it, so I can send you a link.
So guys, I want to talk about the structural point of view of using geopolymers. I think that's a very big concern.
Piruz, I don't hear you well. Can you raise your voice?
How about now? How about now?
Yes, this is good now. This is good.
All right. I want to talk about the structural point of view of using geopolymers. That I think it may be a big concern. The Portland cement concrete has relatively similar coefficient of thermal coefficient expansion with steel, but the geopolymers do not. So it may cause problems due to expansion and compaction for heating and cause cracks. And so it would be I think, big concern for using geopolymers for structural applications. What do you think, Steve or Dr. Sobolov?
Yeah, I would say that that is one of the reasons that geopolymer cement concretes were not used in a lot of reinforced concrete structures. They were used mostly in pavements. You have to realize the comfort level of the structural engineer is, they have, decades of experience with Portland cement concrete. Here's this new kid on the block, geopolymer concrete. So how is it going to perform relative to corrosion of the reinforcing steel? And so, that's a very good question. How will this perform in that function? I believe that these are problems that can be overcome, but it's a matter of risk and comfort that the specifying engineer has with using a new material like this.
I found this the process. You can see the link. And they have another chlor-alkali process. So they use electrolysis. So basically you have sodium chloride solution, and you have electrical current is passing through, and you have chlorine gas and sodium hydroxide. So you have a link, and you can look at this. So using electrical current is not a bad idea, especially if we have a cheap source of electrical current. It means you still need to have, if quantities are huge, you need to produce electricity first, and after you use electricity to decompose the brine, which is sodium chloride, which we have. We know at least raw materials are widely available, but what we do with chlorine gas, I have no idea. I don't know if it is captured or it is dissolved in water to get hydrofluoric acid. Most probably this is the case. So what I'm saying, if you look at environmental aspects of this, I don't know if Beirut, you can bring the paper, the link to the paper, which I have an announcement. This one, the link to ETH paper.
Yeah, let me try.
Can you hear me, guys?
Yeah, we can hear
Yes.
you.
The paper was from ETH. I can post it right now, so you don't have to search. You just click on the link.
All right, I will do.
Click on this link. Yes, I think Steve, you're right. Seawater potentially can be used, but you have maybe a byproduct of the operation as well. So most probably you need to have pure sodium chloride or calcium chloride. If you speak about KOH.
Yeah. In the homework 3, the first question on subjects for the center, one of the suggestions I thought was very helpful was the use of seawater, and certainly if a technology could be used to use seawater to help make the binder for concrete as well as other aspects, I think that that'd be kind of cool.
Oh, you mean using water as a reaction media? Yes.
Yes.
I think this may work for geopolymer. Again, you have high alkalinity, which is good for corrosion protection. But if you use seawater for the as a mixing water, I think it may still be okay, especially for non-reinforced members. You still will need to adjust setting times.
Mm-hmm.
So
Birus, can you look at this, at that paper?
yeah, the paper is now shared. Can you see it, guys?
Yeah, make it
Yes.
bigger.
Yep.
All right.
So, well, if we look at the research paper, we need to, well, first we read abstract, and me personally, I look at tables and pictures and also look at conclusions. So this is my first spots. So abstract really helping you to understand, but this is basically the comparison of geopolymer versus conventional Portland cement, and they are trying to evaluate and see what is really better. Birus, please share this paper with everyone. Maybe you need to post it on discussion session.
All right.
Okay?
Sure. Sure.
I think it's already
Guys,
posted.
while I'm still here, do you have any questions to me?
The link doesn't include the full paper. I will post the full paper on the announcement section.
Okay, it might be a good idea. So I suggest we look at the, Birus, maybe you can look at conclusions so we can see what are the conclusions. Show us also pictures, maybe tables. No table?
So
What is there?
Yeah.
So what we have in this table?
They have their mixed design of their different geopolymers. There was I think, kind of.
So they compare different products.
Yeah, and the geopolymers were metakaolin, slag,
Birus, I don't hear you well.
and fly ash.
Okay.
Can you hear me now?
Yes, I can hear you now.
Yes. Yes.
Very good. And there are different kinds of geopolymers, and their mixed design here and their compressive strengths are included in the table. So,
Okay.
Yeah, these are very nice compressive strengths that they're getting.
I think it's very good summary.
yeah,
We have slag-based, geopolymer based on fly ash, and geopolymers based on silica fume, right?
metakaolin.
Clay.
And clay?
Clay.
I think there were metakaolin, fly ash, and slag. So
Okay.
here we can see their environmental impact of different geopolymers. That is the kind of the analysis you've done, similar to the analysis you've done in your homework 3. These are all the environmental impacts.
Maybe Birus, show us final conclusions. What is the
Alright.
conclusion there? Maybe it's interesting to look at conclusions, what they say. Maybe make it bigger so it's visible on the screen.
Can you see
Just conclusion portion.
easily now?
Well, it's better.
What's interesting is the statement that the results show that the production of most standard types of geopolymer concrete has a slightly lower impact on global warming than standard ordinary Portland cement concrete. Interesting.
Slightly, not drastically.
Not drastic, just slight.
The production of geopolymer has a high environmental impact regarding other impact categories than global warming, and heavy effects on the production of sodium silicate solution. And this is most important phrase, I think.
Yep.
And I think this is most important phrase because sodium silicate, again, is not that green and fluffy and nice product. It is high-end product of chemical industry, which has a sophisticated process and large volumes of byproducts normally. Again, if it is just electrical energy and source of sodium chloride, and you have as a byproduct chlorine gas, which is in the form of hydrochloric acid, which is also fuel, it might be zero waste product process. But we need to look at this because there are different methods. So this electrical decomposition might be interesting method. But again, what are the consumption of electricity, you know, to produce the ton of the product? Is it comparable to production of alumina, for example, which is also using for the electrical source? So this is, I think, something we need to look at. Guys, I may need to leave shortly because I will have a boarding in a few minutes. And I will be, if you need to reach me, we can have a teleconference on Tuesday. I can make a special teleconference if you have any questions on Tuesday with different groups. Is it okay? Looks like it is okay. So, please continue discussion. I'd like really to follow up on wood production and the wood impact, basically based on lecture. Why it is still demanding in terms of energy, in terms of emissions. Okay, and definitely discussion on the project, economical impacts. I'll try to listen to the discussion, but I need to move towards the gate. So good luck with the rest. Keep me posted by email. And again, I will be ready for next Tuesday to meet individually with groups, but to send requests. Okay?
Okay, very good.
Okay. I'm
All right.
switching off.
Anything else on geopolymer? Any other questions? Okay.
So let me bring up the wood lecture. Steve, one of the kind of questions I had is we know the benefits of other construction materials like concrete, but why using wood as construction material is so kind of relevant in US and Canada?
Yeah, the main reason is, well, there's a few reasons. One is supply. The U.S. and Canada have a tremendous supply of wood. The other thing is cost. Wood construction is a fairly low-cost construction material, and we have a workforce of carpenters who over the decades have really perfected the use of wood in construction. So this is why we find that most houses in the United States are made with wood. Is that it simply is the cheaper alternative. A concrete home basically can cost anywhere from 10 to 20% more than a traditional wood stud frame house. And so that's why you find wood to be the predominant material used in the housing market. So simply a matter of cost and availability.
Professor, and if you compare like durability, like how,
Durability.
yeah, this word, sorry. But because I'm thinking like if you are you have a house with concrete or bricks, regular bricks, looks like it takes more time, lifetime. It has a larger lifetime than wood. I don't know if it is just my impression, because I feel kind of wood structures, of course, can be like 100 years, like the professor showed last lecture, but I feel like concrete and bricks, like regular bricks, are more durable. And comparing like these lifetime, do you still think wood houses, wood structures would be better than if people here use like concrete or bricks?
Yeah, if you look at, I'm going to give an example. I have some friends that live in Austria, and the home that they live in has been around for 4 generations. This is a stone home, and so it's been there for 100 and some years, and extremely durable. That home will be there for the next 100 years without any trouble. So really what you're talking about is what is the expectation by the consumer in the life of the structure. So a lot of cultures have used stone to build with, and those structures have shown to last for hundreds or thousands of years. Wood is just not going to do that. Now the problem is that most purchasers, homeowners, don't think of the life cycle of the product, the property that they're buying. And in fact, most people probably will only have that particular home for 5 years before they have to move due to a job, or they need a larger house because of the family has grown in size, or whatever. The culture, the American culture anyway, does not think in terms of long-term, 50 or 100-year cycles. So culturally, you will find some countries where the culture is that yes, the people who build the home want the home to be passed down to their great grandchildren. So that's why you may find in some places people will build with concrete, stone, brick, to build these really durable structures that will survive floods, fire, hurricanes, tornadoes, whatever. There is a movement to address some of this in North America, to basically try to have people think more about the long-term investment and even the short-term investment, because quite frankly, you can really save a lot of your energy costs, heating and cooling of a home or a building, by using concrete, stone, or brick from the thermal mass aspect. Whereas with a 2x4, wood stick frame, you have to use a lot of insulation in the walls to achieve a high enough R value to really reduce your costs. And many of the codes don't really push that to the extreme. We have the ability today, and many of you will be designing what are called zero energy homes and office buildings. These structures do exist. There are architects and engineers who specialize in producing zero energy buildings. And these buildings often are made with concrete. So I really see this as the country becomes more concerned about sustainability. I see a greater opportunity for concrete and similar materials to become more popular in the building market. But that's basically why we use wood in this country more than other materials, is because of the low cost.
Yeah, because I was thinking like comparing the structures. Like here, if you have a problem in the bathroom and you have a lot of water, sometimes you can damage your wood beams. So you need to replace it or have like a huge problems because the wood is damaged because of the water. Of course, the concrete, depending on the situation, like a lot of water with the years, we will have like kind of the same problem. But I feel here like you can have problems with termites or mold, and everything looks like small, like, oh, I have a mold problem. Okay, so if you think it's easier to fix, like dry, apply products, but the damage the termites or the mold make for in the structure, wood structure, it's kind of huge if you compare any problem you can have in concrete structures.
Yeah.
So you said because of the waste as well. But imagine if here a wood house, like people rebuild ever, I don't know, 20 years. I have no idea how long it takes, but 20 years. And comparing with the waste, like every 20 years you rebuild something, and compare with concrete or bricks. We use a lot of bricks in Brazil as well. But
yes.
one house, like my house in Brazil, is kind of new and have like 20 years, I guess. But I have friends with 50 years house, apartments with 60 years, 100 years, and they are very good yet. Of course, they have main things, like they need to remodel and fix some stuff, but you maintain like the building for 50, 100 years or more. So if you compare with the waste, like you produce, of course, wood, it's more environmental because it's not like concrete that stays like there forever. But comparing, do you think like he rebuilding like more time, a lot of times, compare with you have like a house that at least like 100 years, it's worse to have this situation, like because you produce more waste? Or I don't know if comparing, if it is some like big problem because it's wood, it's eco-friendly and concrete not. So what do you think about it?
Well, the whole issue of whether wood is eco-friendly or not is really debatable, because at the end of the day, at the end of the structure, the wood it's going to either be burned or it's going to decay, and the CO2 is going to go back into the atmosphere. But you're exactly right. A concrete structure will not have the problems of water from bathrooms that leak. It's not going to have termite problems. It's not going to be destroyed due to hurricane, tornado, etc. Even in Chicago, there are oftentimes fires in condos, in the concrete condos. The newspaper doesn't even bother reporting these things anymore because it's no big deal. So you have a fire in one condo, the fire is contained by the concrete. So what? No one is impacted. Whereas if that building is made of wood, well, it could be a real serious problem. I didn't catch that.
Hello.
We can hear you. Darius, are you
Can
trying to post something?
other students hear Steve? Because I have problem with hearing and seeing his video.
Okay, so the video is not coming in.
Guys, can you hear me?
We can hear you, yeah.
All right.
Yes.
I think we have now 20 minutes. I think it's time to switch to the groups and see what they are thinking about economical point of view of their business project. So who gonna be presenting for group one?
Melissa, do you have group one?
Marisa, Ivan, Zoris, or Kai? So Melissa,
Melissa is having connection problems.
yeah.
We just lost her.
So how about the other group members? For now, we may switch to group two till Melissa, who is the leader of group one, comes back.
Sorry,
So-
my Wi-Fi just cut out.
All right.
All right.
Yeah.
Melissa, go ahead, please.
So I think I missed the first part when my Wi-Fi was cutting out. Are we just presenting on the economic efficiency?
Yes, if you could just give your update for your group on your project, please.
Yeah, so we talked about the economical efficiency of the business, and we found some resources on how to plan to make a profit for a concrete company. We have to decide if we want to just have it, like what fixed price we would want it and what materials and supplies and equipment we need. And we also found another resource on a company that is similar to ours, and they talk about some of the experiments they have done. So we just have been researching a little bit more this week.
All right.
Melissa, anything else?
Do you have any other updates, Melissa?
Sorry, I'm having troubles with my mic right now. But yeah, basically we have been finding some sources and starting in on the research for our market and how we're going to make money on our product.
Melissa, you cut out again.
Oh, I'm sorry. But that's pretty much as I don't know if you guys heard what I was saying before about how we were finding some sources for the research that we're doing for how to um, market our product and make money off of it.
Okay. Sounds good.
So let's switch to group 2.
Move on to group 2.
Anita or other team members, do you want to talk about your economic plan?
Sure. So we were initially planning on doing just a patent, but now we are going to do maybe a patent, but we're also going to be selling our own product. We have also switched the photocatalytic and photosynthetic coating only to photocatalytic coating for Dr. Sobolov's instructions. And we have determined the formulation that it will be a doped titanium dioxide. So based on that, we have identified some companies from where we could purchase the doped titanium dioxide, as we will not have a capability to be doing the doping ourselves. In terms of dispersing and creating the titanium dioxide coating, we have not yet decided whether we will be doing it on our own. We are exploring whether it's cheaper to invest into equipment or whether it's better for start to partner with a toll blender company or another coating company that they can produce the product for us. We have also done some patent search to ensure that we are not infringing an existing formulation. Obviously, for that, we need like attorneys to be involved for a proper search, but we are doing it on our own for saving some money at the time. As long as we identify that this is something that could be patentable, we might have patent pending, where we will also provide like licensing of the patent later. Then we have identified potential key partners, and based on the interviews that we will get and the feedback from them, we are going to determine like whether it's more economical for us to partner with a coating company to do or a toll blender, or whether it's more economical for us to do it on our own. So this is at this time what we have.
Okay.
Very good, Anita.
Very-
Thank you.
Very good.
Thank you.
So group 3, I know that the leader is not attending this session. So other group members, Jared, Giuliani, Evan, or Jacob, can you please talk about your economic plan?
Okay, I can speak some, and
All right, very
the
good.
guys, if they want, they can complete. I contact the DNR, I guess it's these letters, DNR, and I spoke with them about the rubber and the asphalt. So they sent me some details because I asked them about tax incentives, and they sent me some material today. Actually, they just sent me some emails. So we are studying this part. So they gave us another contacts information so we can speak with them. They offer us to give some samples of rubber, like crushed rubbers. So we are doing this part with them and see what they have. Like they send us like a presentations with details about what they are doing now. So it can be a good help for us to have ideas. My ideas about how to get money, first of all, was tax incentives. I asked them, they don't have it, but probably the DOT or other departments may have, because I found online that they have like federal tax incentives and state tax incentives. I just didn't find yet exactly how much is that, but looks like you have discounts for buying machines, like taxes on these kind of materials to recycle. Other things, the asphalt with rubber, it's cost effective. So it if you compare the regular asphalt with that, it has like longer life. So if you offer then a product with longer life, you can charge more for that because it will have like lower maintenance. So it's not a, how can I explain this? It's have a lower maintenance. So the owner of the road or whatever, they don't need to do regular maintenance, so it's better, so they can save money with that. So I found the article comparing like the costs of the maintenance and the initial costs. So in this article, we figured out like the rubber asphalt, it's better because of that, because it has lower maintenance. Another thing I thought about, it's the future of the companies. The future is for companies that are worried about the environmental. So now it's a difference. So you can choose environmentally options and charge more for that because it's a differential of that. But I believe in the future, because will be like a rule or something like that. The companies we need to do so, who has the technology to reuse materials will be in the top, so sooner the companies adapt and choose more sustainable alternatives, it will be greater, and they will have like a financial return in the future because of that. I think if Gerald is here to talk about the plastic, he can conclude, or no?
I don't see Jared. Jared, oh,
Jeremy and Gerald, none of them are here.
I am not seeing either.
Jared
Okay, so
left the group like 5, 6 minutes ago.
really? Okay, so I'll try to complete the part of the plastic. So the plastic, it's more economic solution because plastic, it's waste. So instead to buying aggregates, you can use the plastic that it's already in the trash, and so it's a cheaper material to use as an aggregate or in the mix. We didn't figure out exactly how it would be, but I guess we are going to use the plastic as an aggregate, as a base, and then the rubber in the mix. And what else I can say about the plastic? So I guess that's all, I guess, because it's cheaper, Probably some cities will give us the plastic because they don't need to take care of that in the landfills.
Okay, anything else?
Oh, I guess that's all.
All right, very good. Thank you.
Very good, Giuliani.
Thank you.
Guys, just keep in mind we have just 4 weeks left for your final presentation on your uh, business plan. So try to be more active and try to kind of have a kind of complete vision of your business idea. Because I think on May 7th or May 8th, we will have the presentation session.
Okay.
But very good. I'm happy with your progress for all the groups. Just keep in mind there is not much time left. So, Steve, in the remaining time, do you want to talk about the alkali activated clinkers and cements and the benefit it has and why the industry is kind of reluctant to implement it?
As you mentioned, we don't have a lot of time left. But first, are there any other questions on the team projects before we move on? Everyone is comfortable with your progress? Okay. All right. Very quickly, the challenge that we have with a commodity like cement and concrete is that it's expensive to make changes. You know, many people will say, you read articles, oh, well, let's change to a magnesium-based cement. Well, that's not easy because cement factories sit on a limestone or a calcium carbonate deposit. Or let's go to higher alkali activated cements and clinkers. Here again, as we just discussed earlier with the article that Beirut posted, alkalis can have their own significant environmental impact. And again, it's not easy to make that change. Portland cement, which is basically a calcium silicate hydrate system, has been used for a long time, since the 1800s. And people are very used to using it. They're used to the engineering properties, and quite frankly, it's a relatively easy cement to make, and the durability and sustainability that it provides, resiliency and so forth, is quite tremendous. So it's very difficult to change that formulation. Now, what has been happening is the cement companies managed to modify the cement specifications so that other chemistries can start to be used. For example, if you go before the year 2004 in the United States, limestone was not allowed to be added at the milling to the cement. The Europeans have been doing it for 20 years, and the Canadians for over a decade by that time. But it's only recent that Portland cement is allowed to have 5% limestone added, which directly reduces the carbon footprint of the cement by 5%. You can also purchase today cements that contain 15% limestone, or limestone cements, and they can be used just like any regular Portland cement and have the exact same properties. And that then allows you to reduce your carbon footprint by 15%. There is a standard called ASTM C1157, which is a performance-based hydraulic cement specification that does allow alternative chemistries. Unfortunately, that specification is rarely used. I think only 6 departments of transportation allow that specification to be used. So there are huge challenges from both the producer and the user on changing the chemistry of concrete. Now, similar things can happen in the steel industry and so forth too, but concrete, which can have numerous formulations, basically the producers and the users like to stick with what they know best, and that is a calcium silicate hydrate system that the Portland cement provides. Yes, there are other compounds in there, aluminates and irons and so forth, but the bottom line is that it's very difficult to make changes. We had earlier talked about the alkali activated geopolymer cements that were introduced back in the 80s and 90s. and they basically were not accepted because it was such a different chemistry, and people just didn't know what to do with it. It had to be handled differently. It had a much shorter shelf life, and so there were other challenges. But in short, you can make concrete, which is basically an agglomeration of sand and aggregate that's glued together by some sort of binder, be that Portland cement, calcium aluminate cement, asphalt, other glues, epoxies, and so forth. But Portland cement is the thing that most people are really used to using, and that's why it is used in over 90% of the concrete structures. We are quickly running out of time. Are there any other questions on geopolymers, the team's assignments, or